You are given a text string S and a pattern P, dot matches any one character. Star matches 0 or more copies of the previous pattern symbol. Decide whether the pattern matches the whole string. Example 1, S is A, pattern is A. The lone A matches only the first character, the second A is left over, so the full string does not match. The answer is false. Example 2, S is still A, but the pattern is a star. The star lets the A repeat, so both characters are covered. The answer is true. If regular expressions only had standard characters and the dot wildcard, matching would be a breeze. We would walk through both strings together. If the characters match, or if the pattern has a dot, we move forward. It is simple, linear tracking. Then we meet the star, and matching is no longer a straight line. New example, S is AAB, pattern is a star B, pointer J lands on the A right before the star. That star does not move forward like a normal character. It expands into a fork in the road. Path A, skip the A, 0 occurrences. Path B, take one A and keep matching on the star. In the first universe, we assume the star means 0 copies. We ignore the character entirely, leap over the star, and see if the rest of the pattern can match our text. This is our safety valve. It is how a pattern like a star B star C star successfully matches a completely empty text string. In the second universe, we want to use the star to crush a character. If our current text letter matches the pattern letter, we consume the text letter and advance our text pointer. But notice, our pattern pointer stays completely still. Why? Because the star might want to eat another duplicate letter on the very next step. If we just let these universes multiply, our algorithm would explode with redundant work. To keep our engine incredibly fast, we lay down a grid of memory. The moment any path uncovers an answer for a specific pair of coordinates, it saves it. If another timeline wanders into the same spot, it instantly reads the saved answer instead of recalculating history. Memoization collapses repeated branches. Next we plan ahead with a table. Do the first I text characters match the first J pattern characters? 3 small examples, we pause on the cells that teach the rule. For the character pattern, cell 11 is true. The first letter A matches the first pattern letter A, building on the true cell at 00. At cell 22 the match is true. The text letter B matches the dot in the pattern, building on the true cell at 11. At cell 12 the star forces a choice. Skip treats a star as 0 copies, look at cell 10, which is false. Or consume 1A, the letter before the star matches our text A, so we lean on cell 02, already true from 0 copies. At cell 22 we finish. Skip at cell 20 is false. Consume, the second A matches the letter before the star, building on the true cell at 12. Each cell is decided from neighbors already solved. The final answer sits at the bottom right. We fill the table for S equals A, B and pattern C star dot star B. Whenever a cell becomes true, we trace which earlier cells made it so. Empty text and empty pattern match. We seed the corner with true. C star means 0 copies of C, skip leans on cell 00, already true. Dot star also allows 0 copies. Skip leans on cell 02, already true. Dot matches the first A. We build on cell 02 where the prefix already matched. Another star. Skip at 12 is false, but consume matches A with dot star using cell 04. Second text row. The star consumes the second A using the true cell at 1-4. Third row. Dot star consumes using cell 2-4, which already matched the first two letters. Final cell, B matches B, built on 2-4. The full string matches the pattern, true. The answer is true at the bottom right. Space optimization, row I only needs row I-1, so previous and current arrays replace the full grid. Watch row 3 land in current, then slide into previous for the next round. Space drops from an M by N grid to order N. Let M be the text length and N the pattern length. Time is order M times N, every table cell is filled once with constant work. Space is order M times N for the full grid, or order N with 2 rolling rows. Learn the two-dimensional table fill first so star skip and consume make sense. This is the same logic with only previous and current rows. Function is match take string S and pattern P. Let M be the text length and N the pattern length. Previous row has length N plus 1, all false. Set previous 0 to true for empty versus empty. For each pattern index J from 1 through N. If the pattern symbol is star, set previous J from previous J-2 for 0 copies on an empty row. For each text index I from 1 through M. Build current row all false, any index we do not update stays false. For each pattern index J on this text row. If pattern at J is star, skip reads current J-2, meaning 0 copies of the starred piece. Eat reuses previous J when the letter before star matches the text char or is dot. Current J is skip or eat. Else if the text and pattern characters match, or the pattern is dot. Set current J from previous J-1, otherwise it remains false. Copy current into previous for the next text row. Return previous at N, the full match answer.